Hello everyone, by this time we're going to calculate another problem, but take note, at this point in time, we're going to concentrate with the Psad category of Civil Engineering Licensure Examination. Let us now start solving one problem, and this is our problem number one in our series of problem solving problems. First and foremost, allow me to read the problem first. A hollow steel tube with an inside diameter of 100 millimeters must carry a tensile load of 400 kilonewtons. In this situation, we need to determine the outside diameter of the tube if the stress is limited to 120 meganewton per square meter. And this is our illustration. In this particular situation or a problem, as we can see in the figure, the inner diameter of a hollow tube is 100 millimeters. And also given in the figure is the tensile load of 400 kilonewtons. In this problem, we need to determine the outer diameter of the tube if the stress is limited to 120 meganewton per square meter. Now, how do we solve the problem? Actually, this particular problem is under the category of normal stress. Let us now start solving the problem. But by the way, do you still remember the formula for normal stress? Normal stress is actually equal to the tensile load over the cross-sectional area, or normal stress is equal to P over A. But in this case, let me give you the formula as tensile load is equal to normal stress to be multiplied by cross-sectional area. And in this particular problem, this is the formula that we will use. P is equal to normal stress times the area. But of course, before we solve the problem, let us start having our givens first. For our first given, we have the tensile load of 400 kilonewtons, or this is also equal to 400,000 newtons, since 1 kilonewton is always equal to 1,000 newtons. But of course, we also have our normal stress value that is limited to 120 megapascal or 120 meganewton per square meters. And since in our given figure, as we can see, there are two diameters. We have the inner diameter consisting of a measurement of 100 millimeter and the outer diameter which is actually unknown. That is why we're going to do this formula wherein the area is equal to the area containing the diameter outside. So we have to compute for that area wherein the diameter that we're going to use is the outside diameter, and the area or another computation of area wherein the diameter that we will be using is 100 millimeter. Meaning to say we're going to have difference between two areas. And this is going to be our formula that we will use in this problem. And our area formula now is equal to 1/4 pi d square. D is we are pertaining to the outer diameter minus 1/4 pi 100 square. 100 millimeter here is our inner diameter. And then let's simplify the given formula or computation. Simplifying now our area calculation, we have it as A equals 1/4 of pi to be multiplied by the difference of d square and 10,000. Take note of this, again, D is our outer diameter. Then, it's time now for direct substitution using the formula of P equals normal stress times the area. Let us now substitute all the givens in the given formula. After the substitution process, we now have 400,000 newtons equals 120 megapascal to be multiplied by 1/4 of pi times d square minus 10,000. Simplifying it again, we will arrive with this equation. Coming up next, our calculation process will become now 400,000 equals 30 pi d square minus 300,000 pi. So let's simplify it again. And then we have now d square equals 400,000 plus 300,000 pi all over 30 pi. Now let us extract the square root of both sides so that we can calculate for d, which is actually our outer diameter that we're looking for. Finally, our answer to this given problem, our outer diameter, or the outer diameter of the tube, if the stress is limited to 120 megapascal, our final answer is 119.35 millimeter. But before we end this slide or this video, let us know first the definition of normal stress as an additional knowledge for us. Normal stress is a type of stress that acts perpendicular to a surface. It is the force acting on a cross-sectional area divided by that area. There are two types, actually. First, we have the tensile stress, which tends to pull a material apart. And then second one, a compressive stress, which tends to push a material together. And that's all for today. Thank you, and God bless us all.